Getting into Objective 1. Objective 1 is taking a look at those graphs that we looked at in the introduction to Objective 1, the parent graphs, and seeing what happens when we change the leading coefficient. So if we look at example A, just by the characteristics of the equation, I know that's a linear equation. X is to the first power, y is to the first power. So I'm going to divide both sides by 6. And now I've developed the equation y equals -1/2 x. Now the way these graphs move left and right and up and down is by adding things to the equation after the x. Since nothing was added after the x, I know this graph still goes through the key point 0, 0. But now, what does the -1/2 do? How does it change the equation? How does it change the graph from its parent graph? Well, all this is a slope. So the slope is -1/2. So down 1 over 2. And there you go. There's the new graph. Now, I've already put the domain and the range in. It's still -infinity to +infinity because it uses up all the x's and all the y's, all the way left, all the way right, all the way down, all the way up. So in the other notations that we learned, it would just be like this, -infinity to +infinity, or all reals. Same thing with the range, -infinity to +infinity, or all reals. Now the quadratic equation, by the characteristics of this equation, I know it's quadratic. Y is to the first power, x is to the second power, so it's going to make a parabola, and it's also going to make an up parabola because the leading coefficient is positive. Now again, since nothing was added to the equation after the x squared, the parabola hasn't been shifted to the left or to the right or up or down. So the key point of 0, 0 still exists. But if you might want to know, what does that 5 do? That's where a little XY table would help you out a little bit. When x is 1, 1 squared is 1, and then times by 5 is 5. So my next key point would be 1, 1, 2, 3, 4, 5, right up here. And if I did -1, I would also get +5 because -1 squared is 1, and then multiplied by 5 is 5. So got that going. And this is a parabola, so it's going to kind of sort of look like that. Domain and range, parabolas go out all the way forever to the left, all the way to the right. So we're still looking at -infinity to +infinity, or all reals. The range, 0 is the lowest point of this parabola, but it does touch 0. That's why 0 is less than or equal to y, which is less than +infinity. So closed 0 to +infinity, or all y values greater than or equal to 0. Okay, moving on to the next example, example C. We've got the absolute value graph. You know it's going to make a V, but because of the -1/3 as the leading coefficient, the V is going to go down instead of up. Now there's nothing in the equation after the x, so the V is not going to be shifted to the left or to the right or up or down. The key point on the V is still 0, 0. And the negative 1/3 is simply the new slope. Down 1 over 3, down 1 over 3. So we have a graph that is doing something like this. I've got the domain already all typed out, negative infinity to positive infinity, because it opens forever out to the left and forever out to the right. So another way of writing it would be negative infinity to positive infinity, or all reals. Now on this particular graph, 0 is the highest value that this graph reaches. So it goes down forever and ever. So negative infinity is less than y, which is less than or equal to 0, because that's the high point. So negative infinity with open and 0 with closed. Or another way of writing that would be all y values that are less than or equal to 0. There we go. Now, the last one. Y equals 7 raised to the x power. Simply by looking at the characteristics of the equation, we know it's a exponential growth graph. But the parent function has a 2 in front of it. What is that 7 doing? Well, it's just going to make it grow faster. Again, let's kind of deploy the XY table. When x is 0, 7 raised to the 0 power is 1. So 0, 1 is still the key point, because the equation wasn't changed after the x. So there was no left shift, and there was no right shift, and there was no up or down. So 0, 1 is still the key point. But what happens when x is 1? Well, 7 raised to the first power is 7. So 1, 7. Let's put that way up here. And then, negative 1. 7 raised to the negative 1 power would simply be 1 over 7. So when x is negative 1, y is just at 1/7. It's 1/7 of a unit above the x-axis. So we got a graph that's looking like this. Remember, by the nature of that asymptote, the graph is getting closer and closer and closer to that x-axis, but it's never touching it. So we might as well do the asymptote first. The equation of the asymptote is y equals 0. Now the domain, left and right. Well, it goes to the left forever. It goes to the right forever. So here's our domain, negative infinity to positive infinity, or all reals. Our range. This graph gets closer and closer and closer to 0, but never touches. So we have 0 is less than y, which is less than infinity. So open bracket, open parentheses, 0 to infinity, or all y values that are greater than 0. Now the last part of Objective 1 is what happens if you see some graphs and you're asked for their domain and their range. Okay, I've just kind of free-handed a few of these. Obviously, I've made a down parabola, and the domain of this down parabola would be, it goes all the way to the left, it goes all the way to the right, so it's still negative infinity to positive infinity, or all reals. The range, on the other hand, we kind of have to be a little bit more careful. 1, 2, 3, 1, 2, 3, 4, 5, 1, 2. That point is 5, 2. That tells us 2 is the highest point that this parabola reaches. So the range is negative infinity to positive 2. And I'm going to close that 2 because we actually do touch the 2. We use the 2. So it would be all y values. The range would be all y values that are less than or equal to 2. Now, the next one I gave you was an exponential growth graph. But if you look at the asymptote isn't the x-axis anymore. It's at y equals 1, 2, 3, 4. So y equals 4 is the asymptote. So on the left-hand side, it's getting closer and closer and closer to y equals 4, but it's never going to touch it. Now, domain, it goes to the left forever and ever, and it goes to the right forever and ever. So we're still looking at negative infinity to positive infinity, or all reals. The range, on the other hand, the lowest this reaches, the lights just went out for a second, the lowest this reaches is y equals 4. And it never really does touch y equals 4. So open with a 4, and it goes up forever and ever and ever. So we close the parentheses right there. Sorry, we leave them open. And now, the range values are all values of y that are greater than 4. Now, the last one. The last one is what we call a piecewise function. I've got what looks to be, a linear equation right here. And then maybe this is the left half of a parabola that comes down to here. And then we have another linear equation starting right here. So it's a little bit of a linear equation, it's a little bit of a parabola, and then it's another little bit of a linear equation. Well, domain. This doesn't go to the left forever and ever. As far as the x's are concerned, this graph comes alive at 1, 2, 3, at x equals -3. And we actually do use -3. So I'm going to close -3. And then it goes to x equals -1. But because this is an open point right here, I never really use this point. So it gets closer and closer and closer to -1, but it doesn't touch -1. So I'm going to leave that open. Now we're going to use the symbol that means and. So and it jumps to the other side of -1 and it starts up again. -1. And then it uses all the other x's, on the graph, because not only does it come down to here, but then it goes out that way forever and ever and ever. So that would be positive infinity. Now the range. The range of this graph, we think low to high. What's the lowest point on this graph? Well, the lowest point on this graph is right here at -2. And yes, we do use -2. Now, what's the highest point on this graph? Well, there really isn't a highest point on this graph because it goes forever and ever and ever up as well as going forever and ever and ever out. Now, if you think about, well, what about this hole right here? You're right. There is a hole right here. So in this part of the graph, it wouldn't touch y equals positive 3. But on this side of the graph, it does pass through y equals positive 3. So we do get to say that this graph does use y equals positive 3. So we don't have to account for the hole. We had to account for it left to right, but we didn't have to account for it up and down. So okay. Objective 1, worksheet 1, finally comes to an end with writing the equation of certain graphs. Now, in problems 24 through 32, we go through all 4 of the different shapes, but every single one of them has the key point where it's supposed to be. This is obviously just a regular old linear equation that passes through 0, 0. Absolute value v that has a vertex at 0, 0. A parabola that also has its vertex at 0, 0. And then there's the exponential growth graph whose key point is 0, 1. And sure enough, there it is right there. So all of these equations, all of these graphs are doing what they're supposed to do with the exception of the leading coefficient. The leading coefficient has been changed or could possibly be changed. So in this first graph, all we got to figure out is what is the new slope? What is the new leading coefficient? We don't have to worry about anything on the other side of the x because the graph has not moved around left or right or up or down. Well, finding out this slope is really easy. Just remember, slope is rise over run. So what's it take to get from this point to that point? Up 1, 2, 3 over 5, 1, 2, 3, 4, 5. So the new equation is y equals 3/5 x. There you go. That's the equation of that graph. Now the next one, the absolute value. Almost as basic as a linear equation because both sides are linear. It just happens to be absolute value. Now the v is going down, so you know that that leading coefficient, some people call it the slope because it is linear. Some people don't use m, some people use a, but we do know it's negative because the v is going down. But other than that, it's pretty much the same thing as a linear equation. So y equals 1, 2, down 2, 1, 2, 3, 4, 5, negative 2/5. Y equals negative 2/5 absolute value x. And that's the equation for that graph. Now this one definitely doesn't have a slope. It's a down parabola. Parabolas don't have slopes because the change is not constant. So we definitely don't use an m right there. We just use an a. Y equals ax squared. What is that leading coefficient that makes this graph work? Well, what we're going to need is we're going to need the help of not only the key point at 0, 0, but we're going to need the help of this other point right here, which happens to be at negative 3, negative 5. So all we're going to do is plug in. When the y value is negative 5 equals a, the x value is negative 3. So you can do it like this, negative 3 squared. Just plug in x and plug in y where they belong in the equation. So now you've got negative 5 equals, negative 3 squared is 9, so 9a, divide both sides by 9, and you've got a equals negative 5/9. Now you know your a value. Now you know your leading coefficient. So the equation of this down parabola is y equals negative 5/9 x squared. Now the last one's the exponential growth function. It passes through the point that it's supposed to pass through as long as it hasn't been shifted left or right or up or down. It passes through 0, 1, just like the parent graph does. So you know there's nothing past the x, which tells us one more time the only thing we have to figure out is this, which is not really a leading coefficient, it's the base. What is the base that makes this work? Well, you do the same thing. Plug in. I know my y value is 3 when my x value is 1. So y equals a to the first power, because here's my plug-in for x up here in the exponent. So 3 equals a, some number raised to the first power. So therefore, a must equal 3. Because 3 to the first power is 3. So now that you know your a is 3, you know the equation of this exponential growth graph is y equals 3 raised to the x power. And I believe that finally finishes off worksheet 1.